Assalamu alaikum, dear students. In today's lecture, we will continue our previous topic that was about the uh, contaminated soils, contaminated subsurface. And today we will be more specific to our soil and groundwater contamination. So, firstly, we will look at what are the sources, and then we will work out what is the behavior of soil, how the soil uh, behaves when the water is flowing through it or when the contaminant is traveling through soil and groundwater. So but again, it will be today's in today's lecture it will be only a basic introduction. Then further we will go into the detail by studying some laws which will be uh, ruling the movement of contaminant transport. So something about the basics of soil and groundwater contamination. I think it's very much obvious that we have some specific source which is contaminating our soil, and then from soil we have uh, the contamination of groundwater. Now, how the soil is getting contaminated? In this case, we are having two types of pollution, and first of all, it is the anthropogenic source, and which is normally due to our industrial sources and any man-made sources. And second one is a natural source of pollution. While we are talking about natural source, it only covers those sources which are already taking place for long durations since our uh, earth came into existence. We are having this natural phenomena which is continuously existing in our soil, and that is the degradation of organic content. So this is the major source of uh, natural source of soil contamination. Then we have some sources like some minerals are there in soil due to its typical soil nature or location. Then we have some other options based on which we can say that it is natural source of contamination in our soil. Then we have anthropogenic sources, in which industrial wastewater is the most important example. Landfill site is another example. Dump sites another example. Then we have some hospital waste disposal sites, which is another example of soil contamination. Septic tanks are another example. So uh, there are multi reasons of our soil contamination. Storage tanks, in which mostly the oil tanks and uh, some kind of waste which is directly stored in our soil is another source of contamination. So all these things are discussed here, you can go through them. We are more concerned that once there is a leakage, which is also called as leachate. When leachate is moving in the soil, it is all up to the soil how it behaves and how it deals with that contaminant. So we will be more concerned with that. This is the a typical demonstration. We talked about it last time. Again, we will be looking at it because it is showing that our source is being proliferated, and it is actually contaminating the subsurface, and then it is carrying on the contamination to our groundwater resources. And while the contamination is in our groundwater, it follows the groundwater flow direction. It is carried from one place to the other through the movement of groundwater. We will also study what are the mechanisms to determine the groundwater flow direction, how we can monitor it, how we can monitor the contaminant transport. So there are some options here, and you will again see that this contamination is spreading out. And what is the reason of this spreading out of this contamination? Because the material is volatile in nature and it is not going to settle down. It is lighter in density, so it is going to sustain its position in the top layers of the groundwater. It is not going to uh, s- uh, settle down, and it is not going to uh, deposit at the bottom of the aquifer, but it is going to spread out because of its lighter density and volatile nature. So this is also one of our uh, topics in our coming lectures on which we will be focusing. Now, sources and impacts of contaminants in soil. As I was talking earlier, the most important thing is that how the medium is going to behave. We have two medium, soil and groundwater. Soil have uh, different soil textures, so that texture is important. Then the contaminant is important, so every contaminant has its own characteristics. So based on those characteristics, the soil is going to deal with it. Then whether it is going to retain that contaminant within the soil medium, or it is going to pass it on to the groundwaters along with the flow of the water. So first of all, you should know that we have a very smooth flow of uh, water through the pores of soil if the uh, voids between the soils are having more space, are larger. Then the water is going to flow down and it will percolate to join the groundwaters. So this is one of the major uh, phenomena which is occurring in our soil. This is one of the major examples. On the other hand, if the soil is having a texture which is very dense, the voids are very narrow, and which is hindering the movement of the water through the pores, in that case the mobility of the contaminant is restricted. So most of the cases the contaminant will be retained in the soil. So based on that, we will again look into the different parameters and aspects which are responsible for this kind of behavior of that contaminant in our soils and in our groundwaters. So um, in general, we have two behaviors, that is mobility of the contaminant, leachate of the contaminant. Second is the retention of the contaminant. So both these will monitor, both these will lead the behavior of the lead to the behavior of the soil texture and then the groundwater nature. Here are some of the description. And once the contaminants are in our soil, they where they go and move travel depends on many factors. So what are those factors? These are the nature of the contaminant and then the nature of the soil, and then uh, we are going to have some others like the content which is already existing in soil is also very important, because in some of the cases we have already a hydroxyl group in the soil, we have already an acidic group in the soil, we might have some minerals in the soil, we might have some other heavy metals in the soil. All those are going to react with the incoming contaminant. So these are also the regulating parameters to define whether the contaminant will sustain and retain in the soil or it will move down to the groundwaters. So moisture levels and then presence of other chemicals, pH, all these things are important to determine the fate of the contaminant. So contaminant bioavailability in soil is related with the uh, organic nature, and then it is linked with the uh, behavior of contaminant. It is again, I think we have talked about it already. So as far as groundwater pollution is concerned, we will be dealing with four types. So prevention of pollution, evaluation of pollution, that is the analysis and assessment, then remediation approach for the contaminated groundwaters, and then its rehabilitation, then its conservation, how we can restore the medium, how we can restore the water resource back to its original state. Then we have some environmental problems in narrow definition. So as we talked earlier, the soil texture is very important to define the behavior, and the fate of of contaminant depends upon the characteristics of the soil. So one of the characteristics is the permeability. So the soil expansion of pollution due to low permeability is one of the factors, and then so here is some of the utilization. Moving forward, now we will be talking about the subsurface characteristics. And you know, subsurface consists of two major medium: soil and groundwater. Soil is normally declared as unsaturated zone, and groundwater is concerned as termed as saturated zone. So both have different characteristics, and the behavior of soil, behavior of contaminant is also different. So the particle size distribution, gradation, soil properties related to the mobility and retention, hydraulic conductivity, permeability, porosity, void ratio, all these things are important factors. Then in our groundwater section, the aquifer and its characteristics and unsaturated zone and saturated zones are important. We are concerned with these storage of the aquifers. Groundwater hydraulics, it is about the movement of groundwater, and it again depends upon the aquifer and its characteristics. All these things are important for the determination of our determination and assessment of our contaminated sites. Starting with the very basics, it is something about soil. What is soil? So it is soil is concerned with most of the uh, professions, and most of the it has a very wide utilization. So in civil engineers define them in their own way, agronomists define them in its own way, botanists define them in their own way, horticulture has its own characteristic definitions. You can go through them, and will be talking about the soil particles. When we talk about soil texture, normally it describes the different part ingredients of that soil volume or soil specimen. Normally what our soil constitutes of, it constitutes of clay, silt, sand, gravels, boulders, and rock fragments. So these are all parts which constitute our soil. Now what next is important is their proportions, and how in which proportion these particles are existing in a typical soil specimen. It is an important parameter. And then uh, is the important factor is their permeabilities, and then all these factors will be defining the overall soil specimen characteristics. Starting with the gravel normally which exists in our soil, the size is larger than 2 millimeters. Then sand has size ranging from zero point 0.1 to 2 millimeters. Silt has size ranging from 0.01 to zero point 0.1 millimeter. Clay has size less than 0.1 0.01 millimeters. And then if we have gravels and sand, and it can be roughly classified as coarse textures, while silty and clay soils are classified as fine texture. What is homogeneity and what is heterogeneity? I think these both terms are very much familiar to you. We will be defining them in terms of our soil. So if the characteristics of soil are similar at uh, similar with reference to different locations and different points, then the soil is declared as homogeneous. So homogeneous material properties are same from point to point within the soil mass. So we are having a homogeneous structure with same properties at different locations. While heterogeneity is the reverse, we are having a varied uh, soil properties, varied soil texture along with the uh, uh, length or along with the depth, uh, changing from point to point. Then we have another term, anisotropic. So what is anisotropy? It's the property of being directionally dependent. If the properties of a soil particle is varying from one place to the other, it will be declared as anisotropic. But if it is consistent in a typical direction, then it will be called as isotropic. So in our real scenarios, soil is declared as anisotropic because the properties are not same. We are having different layers of soil and our underground surface. Similarly, we have a non-linear behavior of soil. What is linear and non-linear behavior? It is the relationship between stress and strain. If we are having a directly proportional relationship, it will be giving us a linear behavior. And if we are having a curve, parabolic curve, it will be declaring as a non-linear stress strain curve. So in our case, the soil has a varied behavior of soil of stress and strain, and giving us a non-linear relationship. So here a question arises: what will happen if both stress and strain are having a linear behavior? So it is a question for you as well to think about it, that what will happen if stress is proportional to strain. As much we have a stress, the same is the proportionality of the strain. Or what is strain? It is a deformation. So the deformation is exactly in the same proportion as we are having stress. So uh, from geotechnical point of view and from the stability point of view of any soil or structure, this linear behavior is not recommended and not acceptable for uh, for stability, because it means that soil is not competent enough to bear any load. Then we have this gradation. What is gradation? We talked earlier that when we are going to have a mixture of different types of soil properties, of different soil textures, then it will be called as a graded soil. And more graded soil is going to give us a more consolidated and compacted soil structure. And in this case, more graded structure, the pores between the soil particles are normally filled up with the finer particles. So that means we are having lesser wide ratio, and that means the uh, passage of movement of the water from top to the bottom is not so easily available for to facilitate the movement of water through these pores or voids. So another example of well graded soil is the compacted soil. More the compaction, the lesser will be the voids, because when we compact a soil, the voids are covered, the voids are filled up with the finer particles. There is no more space. So the best example is the lining of our roads, lining of our canals. More the lining, the lesser will be the percolation. And when we are constructing roads, we need the minimum leakage, the minimum infiltration of the water through the road structure. Most of the roads are destroyed only because of the filtration of the water through the road structure. So when the road structures when